Today we're going to start our next chapter, our next topic, and the topic is called rational numbers. We're going to spend probably about a month or 5 weeks on this chapter. So it's a longer chapter. There's some more topics, and it's a little tougher. There's going to be some new material. The last chapter with integers, most of that was probably review. This is going to be a lot of newer material. So our first one that we're going to look at just adding and subtracting fractions and mixed numbers today and tomorrow. So we're going to look at adding and subtracting fractions today. Hopefully, kind of a review, especially some of these vocab words. I would venture to say you've seen them before. So a common denominator is when all fractions in a problem have the same number on the bottom. So the denominator is the number that you see on the bottom of a fraction. The numerator is the top number on a fraction. So we're going to be talking a lot today about denominators and numerators. Make sure you know which one is which. And then unlike fractions, that's fractions that don't have the same denominator. We're going to have to do one step before we can start adding and subtracting those. So when we are adding or subtracting unlike fractions, we have got to do an extra step and get a common denominator. And so we'll talk about that here on our first couple of examples in a second. But we cannot add or subtract fractions unless we have a common denominator. So remember that and make sure that we take care of that if there's not a common denominator before we start to add and subtract. So these are 3 steps we want to follow when adding and subtracting fractions. Step 1 is to make sure we get a common denominator if we don't already have one. Once we've got the same number on bottom, that number is not going to change. It's going to stay the same. From there, we just add or subtract the numerators, the top numbers. So make sure you do not add or subtract the numbers on bottom, just what's on top. And then step 3, we're going to do something called simplify. Many times they'll say add or subtract and then write your answer in simplest form. And that means simplify our answer only if we need to. We'll talk about what that looks like if we need to simplify. Okay, so let's look at our first example. So there's two different ways that we could find a common denominator. So we're going to look at the first way on this first one, 1 over 6 plus 2 over 3. So what you can do is look at 6 and 3. So they are not the same number. We need to make them the same number. Is there a number that both 3 and 6 can go into, can be multiplied to get to? Billa?
2.
What do you mean by 2?
Wait, what did you say?
Is there a number that both 3 and 6 can go into?
Yes, 12.
12 would work. Yeah. What's another number that would work? Charlie? 6 would work too, right? So we can do 12, we could do 6 times 2 and 3 times 4. But if we did 6, do we have to change anything with this 1 over 6?
Yes.
We don't. We just keep it as 1 over 6. All we need to do is change the 2/3. So to change 2/3, we're going to do 3 times 2. And then very important, if we multiply the bottom number by something, we have to multiply the top number by the same thing. So we do 3 times 2, we've got to do 2 times 2. So now we've got still the same problem, it's just going to look a little different. 1 over 6 stays the same, plus now it's 4 over 6. So 1 over 6 plus 4 over 6. 4 over 6 is the same thing as 2 over 3. It just looks different. Now, since they have the same denominator, we can add them. 6's don't change. They stay as a 6. And all we do is 1 plus 4, which will get us 5 over 6. 5/6. So that's step 2. Step 3 is when we simplify our answer. Simplify means, can we divide the top and the bottom number by the same thing? Can we divide 5 and 6 by the same thing?
No.
We cannot, so that's as far as we can go. Our answer is 5 over 6. If you had used 12 as your denominator, you should have still ended up with 5 over 6, but you would have had to simplify once before you did that. So you'll still get the same answer. It's not going to be wrong, but you will need to simplify. Since we use 6, that's the least common denominator, the smallest one we could have used. You don't have to simplify this time. Okay, so let's look at our next one. 9/10 minus 5 over 7. What would be a number that both 10 and 7 could multiply into? There's only really one that would work, Josh. 70. So another way, and this way always works, even if it doesn't get you the least common denominator, it will always work to get you a common denominator. Just multiply the two denominators by each other. So we'll do 10 times 7 and 7 times 10. In this case, that's the only one that works. So we got to do that one. Now if we did 10 times 7, we've got to multiply 9 times the same thing. We did 7 times 10, we've got to multiply 5 by the same number. So make sure the top and the bottom is always multiplied by the same thing. Top and the bottom always multiply by the same thing. So then rewrite our two fractions. We've got 63 over 70 minus 50 over 70. Since we have the same denominator, now we can subtract and just subtract what's on the top. 63 minus 50 would be 13 over 70. And then, like I said, always look to simplify. Can 13 and 70 be divided by anything?
No.
Now, 13 can only be divided by 13, and 70 can't be divided by 13. So that's in simplest form. That is in simplest form. Okay, so you all go ahead and do the next two on your own. Do the next two on your own. Alright, for our first one here, 1/4 plus 3/8. What would be a common denominator for 4 and 8, Fiona? 8 would work. So if we use 8, 3/8 doesn't need to change. We just need to multiply 1/4 by 2. So make sure you multiply the top and the bottom by 2. That's going to get you 2/8 plus 3/8. And then now that the denominator is the same, add the 2 plus 3 and get 5/8. Do we need to simplify this? We do not. So 5/8 would be our answer. What's a common denominator for 5 and 12? So what's actually really the only one that would work for 5 and 12? Sabrina? Yeah, multiplying by each other. So do 5 times 12 and 12 times 5. That'll get you 60. You also need to do 2 times 12 and then 5 times 5. So that will now get you 24/60 plus 25/60. And then add 24 plus 25, which will be 49/60. Can 49 and 60 be divided by the same thing?
No.
Cannot, no. So 49/60, that is in simplest form. Okay? Any questions about these first 4? Okay, so the next couple of examples, now we're throwing in negatives and positives. And this is where in 7th grade we start to step it up a little bit from what we did in 6th grade. If we have negatives and positives, so one thing I want you to make a note of is that the positive and negative rules are the same for fractions. So we're going to follow the same positive and negative rules for adding and subtracting, as well as for multiplying and dividing for fractions, as we followed for integers. Which means, if we are subtracting something, we want to change those two things, remember. Change the subtraction sign to an addition, change the sign of the second fraction. So this is going to be rewritten as negative 2/3 plus negative 1/2. Since the whole 1/2 is negative, you can just put the negative sign in front of it like that. So we're going to rewrite it. Since they are both negative, do we add or subtract them if they're both negative? We add. Same sign means we add them, okay? So we're going to add these two, but in order to add, we need to get a common denominator. And for 3 and 2, the least common denominator would be, Charlie? 6. So just do 3 times 2 and 2 times 3. So now we're going to get negative 4/6 plus negative 3/6. Negative 4 plus negative 3. Add those, we get negative 7. Negative 7/6. Yes. Do we need to simplify? Yeah, we do need to simplify. Now 7 and 6 won't be divided by the same number, but what do we need to make this negative 7/6? We need to make it a mixed number, yes. So to make it a mixed number, for today, most of the time it's going to be a little easier. We can just do it like this. How many times does 6 go into 7? 1 time. So we need to keep this as negative 1. And then if we take 6 away from 7, how much are we left over with? 1/6. Yep. So negative 1 and 1/6 would be our answer. Negative 1 and 1/6. So we're still following those same addition and subtraction rules like we did last week. So let's look at our next one. So we've already got the addition problem. We don't have to change that. If one is negative and one is positive, do we add or subtract? Subtract. So we're going to actually subtract these. We're going to do 5/8 minus 1/6. 5 over 8 is bigger than 1 over 6. So our answer is going to be negative. Because 5 is more than half of 8, so this is greater than 1/2. 1/6 is less than 1/2, just a smaller piece. So our answer is going to be negative. And all we have to do is 5 over 8 plus 1 over 6. Now, what would be a common denominator that would work for 8 and 6? Bill? 24 would work, right? 8 times what? 3, and 6 times? 4, yes. Could we have used 48 and just done 8 times 6? Yeah, we could have done that as well. We'll stick with 24. So we got to do 5 times 3 and 1 times 4. And I'm just going to pretend like they're positive because we know that we're subtracting them. So we're just going to do 15 over 24 minus 4 over 24. As we said, since they're different signs, we would subtract them. 15 minus 4 would give us 11 over 24. So remember we said our answer was going to be negative because that 5 over 8 is going to be bigger than 1 over 6. Can we simplify 11 over 24?
No.
Can't. So our answer would just be negative 11 over 24. Another way that you can see, if you don't know if 5/8 is bigger than 1/6, wait and make that decision until after you get the common denominator. Is it a lot easier to see which one's bigger now? 15 is bigger than 4, right? 15 over 24 is more than 4. So if you want to wait until you get the common denominator, then you can see, okay, which one's bigger? 15 is, so 5/8 is the bigger number, which means our answer needs to be negative. Okay? So you can always wait till after you get a common denominator. Yes?
I'm sure because if the numerator on one side is bigger, then it's gonna probably be the bigger number.
A lot of times that's the case. There'll be some later on, like if this was 3/4, that 3/4 would be bigger actually. So that doesn't always work, but if it's the same denominator, you just look at the top number. Okay? So you all go ahead and do the next two. Okay, for our first one here, 4/9 minus -1/2. Make sure you change those two things because subtraction. Change the minus sign to a plus sign. That -1/2 becomes a positive 1/2. So now it's really just an addition problem. 4/9 plus 1/2. For 9 and 2, what will be our common denominator? For 9 and 2. Okay. 18. So 9 times 2 and 4 times 2. 2 times 9 and 1 times 9. So that's going to get us 8/18 plus 9/18. Common denominator is 18, so we just do 8 plus 9 to get 17/18. And that will be our answer. Our next one, -9/10 plus -1/4. If they're both negative, we just add them. Yep. So -9/10 positive or -1/4. What's going to be our common denominator for 10 and 4? There's a few that would work. What's one of them that would work? 20 would work, right? Would 40 work as well? If you want to do 40, you could do 40. But we'll do 20. So 10 times 2, 9 times 2, and then 4 times 5, and 1 times 5. So that's going to get us -18/20 plus -5/20. So obviously now you can see -18/20, that's the bigger number. And that's a negative number, so your answer is going to be negative. 18 plus 5 would give us -23/20. What do we need to do with this -23/20 though? Alex? Simplify it. How many times will 20 go into 23? Once. Keep that negative in front of it. If we take 20 away from 23, we're left over with 3/20. So our mixed number would be -1 and 3/20. So just use the same rules that we use for integers for fractions. Now, any questions? All right, so our last one. So in one town, 3/20 of the dogs are German Shepherds, 7/25 Golden Retrievers, 2/5 are mixed breeds. How many more dogs are mixed breeds than German Shepherds? There's some key words that we're going to talk about throughout this chapter that help us know what operation to use. The phrase, how many more? It always means to subtract. So the phrase, how many more, means to subtract. Does order matter when we subtract? Does it matter which number comes first?
Yeah.
Yes, it does. Okay? 2 minus 4 is not the same thing as 4 minus 2. But this tells us there are more mixed breeds than German Shepherds. So mixed breeds is going to come first, because that's the bigger number. So 2/5 mixed breeds minus 3/20 are German Shepherds. So 2/5 minus 3/20. So we've got 5 and 20. What would be a common denominator for 5 and 20? Charlie? 20 would work, right? 5 times 4. So then do 2 times 4. We don't need to change 3/20 because 20 is our denominator. So rewrite 2/5 to 8/20 minus 3/20. 20 is the denominator, so just do 8 minus 3, which is going to get us 5/20. Can 5 and 20 be divided by the same thing?
Yeah.
Yes. So do we need to simplify?
Yes.
Yes. What can 5 and 20 be divided by?
4. What?
Okay. So yeah, what did you divide by to get that? 5 divided by? By 5, yes. Yeah. 5 divided by 5 and 20 divided by 5. You divide both by 5, then you get 1/4. So there's 1/4 more mixed breeds than German Shepherds. So when simplifying, if you can divide both the top and the bottom by the same number, do that. Get that simpler or smaller fraction, and then we're good. Any questions on that? All right, so we got a few problems to work on.